Hi, welcome to lesson 3.1, Pairs of Lines and Angles. Now, this is your chapter 3 journal. You guys need to pause the video and tear out pages 65 to 90. Okay, so the journal for chapter 3 is pages 65 through 90. Now, right now we are on page 65, and today's question is, what does it mean when two lines are parallel, intersecting, coincident lines, or skewed? And we're going to talk about what each one of those means in just a moment. So our very first thing is, what does it mean when two lines are parallel? Two lines are parallel if they are in the same plane, meaning that they are what we call coplanar lines. They're in the same plane, and the lines do not intersect. So the number of intersections in a set of lines that are parallel is 0. In a diagram, you can tell if a set of lines are parallel by looking at the little arrows facing the same direction. For example, in this diagram, you have these two lines with these two arrows right in the middle of them, going in the same direction. That means that those two lines happen to be parallel and they're in the same plane and they do not intersect. Now, if two lines intersect, they will intersect at exactly one point, which is this one right here. Coincident lines are two distinct lines that lie one on top of the other. So any point on that line is considered an intersection. So the number of intersections in a set of two coincident lines is infinite. The symbol for infinite is like a sideways 8. Now for the second exploration, we have this example where we are going to classify the relationships between the two lines. Now we are on page 65. Now, the figure shows a right rectangular prism. In other words, like a box. All its angles are right angles. Classify each of the following pairs of lines as parallel, intersecting, coincident, or skewed. Note that two lines are skewed lines if they do not intersect and are not coplanar, meaning that they're not in the same plane. Our first example is lines AB and BC. So lines AB and BC, that's this line and this line, they both have a common point of intersection called B. So these two lines are said to be intersecting. Okay, because their intersection is at B. Both lines intersect at B. Now, line AD and BC. AD and BC, they're both in the same plane, which would be the top plane, and they do not intersect. So here, the relationship between these two lines is that they are parallel. Why? Because they do not intersect. And also, they are coplanar. Lines EI and IH, EI, that's this one, and IH, notice that they're not talking about segments, they're talking about lines. So line EI happens to be this whole line, and IH happens to be this whole line as well. So therefore, they are the same line, which means that if we were to classify them, they're going to be coincident lines. And I know I'm spelling this wrong. Coincident lines. And why? Well, because they happen to be the same line. They overlap each other. Now the next two can be a little tricky. Okay. So you have line BF, okay, that is this line right here, line BF, and line EH. line EH. As you can tell, these two lines do not intersect, and yet they're not in the same plane. So that's why we call these lines skewed lines. Okay, the reason is because they do not intersect, and they're also non-coplanar. Now, EF and CG. EF and CG have the same situation as D. Okay, so these two lines do not intersect. EF and CG do not intersect, and they're also not in the same line. So we say that these are also skewed lines for the same reason. They do not intersect, and they are non-coplanar. Now, let's look at the next one. You have line AB and GH. So I'm going to use a highlighter so that you guys can see what those two lines are. That's AB and GH. Now you're probably thinking, well, they do not intersect, but they're not in the same plane. So they must be skewed. You're wrong. They are not skewed. These are actually parallel. But Mr. Asuna, they're not in the same plane. Wanna bet? You can actually draw a plane, and it's the plane that exists. There is a plane that can exist that can contain both of those lines. It's the plane that is pretty much kind of like the diagonal plane, you would say. So yes, these two are actually parallel. Okay, these lines are parallel, and it's because they do not intersect. And they're also coplanar. Okay. All right. Let's take a look at our third exploration, which is on page 66. Okay, what we have here now is two sets of lines that are parallel cut by a third line that we are going to call that our transversal. Okay, a transversal is a third line that cuts through two lines. Transversals don't always have to cut through two sets of parallel lines. In this case, it does. And now let's talk about our prior knowledge. What are some things we do know about intersecting lines? Well, we know that when you intersect two lines, you get a set of vertical angles. You get four pairs. Two pairs, I mean. But since you got two lines, you're going to get a total of four pairs. Now we're going to identify all the linear pairs as well. So if we look at the vertical pairs first, these are the angles that are right across from each other, and the only thing that they have in common is the vertex. For example, if we look at the left-hand side of this, we can see that we have 1 and 3. So angle 1 and angle 3. If you hear kids screaming in the background, that's my son. So 1 and 3 and 2 and 4. Okay? Now, if we take a look at the other side, we are going to have angle 5 and angle 7 and angle 6 and angle 8. Now, we already knew from our prior knowledge that all vertical angles are congruent. So vertical angles are congruent. We already knew that. It's nothing new. So what about linear pairs? Linear pairs are two angles that are adjacent to each other, meaning that they share a common side and a common vertex, and they form a straight angle. In other words, a straight line. So there are several of these pairs. The first one is angle 1 and angle 2. Angle 4 and angle 3. angle 5, and angle 6, angle 8, and angle 7. Now those are the ones that are going horizontal. Now let's look at the ones that are going vertical. Angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8, angle 6 and angle 7. Now we know that all of these here are linear pairs, and we know that linear pairs are supplementary. So we are going to be needing this knowledge pretty much for the rest of the textbook. So please make sure that you guys are aware of what are things that you guys need to know. Okay, now let's turn to page 67. Now on page 67, this is where your examples are going to go. Right next to the word parallel lines, you're going to put problem number 1. Right next to consecutive interior angles, you're going to put number 2 on page 67. Now, please turn your page to page 68. Now, on page 68, you are going to write problem number 3 right here where it says notes. Now let's talk a little bit more about parallel lines, skewed lines, and parallel planes. As you can see in this diagram, you have quite a bit of vocabulary for us to look at. Okay, so two lines that do not intersect are either parallel or skewed. Okay, two lines are parallel lines when they do not intersect and are coplanar. We already mentioned that. Two lines are skewed lines when they do not intersect and are not coplanar. So the difference between parallel lines and skewed lines is that parallel lines are coplanar, skewed lines are not coplanar. Now, when two planes do not intersect, we also call them parallel planes. Here's a little bit of notation referencing to this diagram right here. Lines M and N are parallel lines. Why? Because you can see that they both lie on the same plane called T. Lines M and K are skewed lines, so M and K are skewed lines. Now, why do we say that they're skewed lines? Because one, they do not intersect, and K is not on the same plane as line M. M is in plane T. Plane T and U are parallel lines, and this is the notation, T parallel to U. The two little lines like this, looks like an 11, it's a symbol for parallel. Now here, lines K and N are intersecting lines, and there is a plane that can contain them. So how do we know that there's a plane that can contain them? Keep in mind that it takes 3 non-collinear points to make a plane. So not only do you have the point of intersection, but you could have a point that is on K and on N, and you can make a plane out of those 3 points. So our symbol right here means is parallel to. Now, segments and rays can be parallel, okay, when they lie in parallel lines. A line is parallel to a plane when the line is in a plane parallel to the given plane. In the diagram above, the line N is parallel to plane U. So in other words, if these two planes are parallel, and there is a line on this plane is parallel to that line. It just takes a little while for you guys to be able to, see all the visuals. Now, one of the most important postulates in this lesson is called the parallel postulate. Now, what exactly is the parallel postulate? The parallel postulate just means that if you have a line and you have a point not on the line, how many lines can I draw going through this point that are going to be parallel to this line? Could it be 1, 2, 3, 4, maybe 5 lines? Well, the parallel postulate only allows us for 1. So I can draw only one line that is going to be parallel to that line going through that point. It's called the parallel postulate. So if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. That's called the parallel postulate again. All right, page 69. Similarly, you have the perpendicular postulate. If you have a line and you have a point that is not on the line, how many lines can I draw going through that point that are going to be perpendicular to that line? And the answer is obviously only one. There only exists one line going through that point that is perpendicular to that line. Now, in lesson 3.1, we get introduced to the 4 angles formed by these transversals. And yes, you are going to be memorizing these terms, and we're going to be applying them in lesson 3.2 and 3.3 when these lines are indeed parallel. Here, the lines are not parallel. Okay, so let's go through some of these. Okay, the first one is the set of corresponding angles. Okay, so 2 angles here are corresponding, meaning that they have the same position on the same side of the transversal. So for example here, 2 and 6 are considered to be corresponding angles. They're on the same side of the transversal. The way I like to remember these is kind of like quadrants. They're in the same quadrant. This one here happens to be in the first quadrant. This one here happens to be in the first quadrant of the bottom part. Kind of like this. If this was an XY axis, this is the first quadrant. If that was an XY axis, that is the first quadrant. Now, the next one is the alternate interior angles. Alternate interior angles, they lie in the interior, meaning between the 2 lines, and they are on opposite sides of the transversal, but not necessarily adjacent. Actually, not completely adjacent. So these 2 angles are alternate interior angles. For this one, we have alternate exterior angles. Okay, alternate exterior angles. They are on opposite sides of the transversal, and they are on the exterior. Now, the fourth relationship that we have is the consecutive interior angles. They are on the same side of the transversal, and the only thing that they share in common is a common side, pretty much. Now, sometimes these consecutive interior angles, sometimes they call them same side interior. So if you see it as same side interior, it's the same thing. Same side interior. Talk about bad handwriting. Come on, man. Interior. All right. So make sure you guys have, copied all the important information. Now we're going to go ahead and get started with our first example. Now our first example, if you remember, it's on page 67. Problem 2 is right next to that. And problem 3 is on the next page. All right, so let's take a look at example number 1. Now remember, pause the video so that you guys can, copy down the diagram and then proceed the video whenever you're ready. Okay, so the first question is, think of each segment in the figure as part of a line. which lines or planes appear to fit the following description? Now for A, they want us to look for lines that are parallel to CD but contain only point A. Okay, so let's take a look at that. So we're going to look for lines that are parallel to CD but can only contain point A. Now the only lines that I see that are parallel are this one, and this one. But the only one that can contain point A is line AB. So for A, it's going to be line AB. Okay, part B. Lines that are skewed to CD and contain point A. So remember, lines that are skewed to CD are lines that are parallel but they're not on the same plane and they do not intersect. So the lines that do not intersect happen to be AH, BG, and AG. So in this part, you actually have two solutions. Okay, so our solution is line AH, that's this one, and also AG. Whoops, AG. All right, which lines are perpendicular to CD and containing point A? Now there are a total of 4 lines that are perpendicular to CD. That would be ED, FC, AD, and BC. Those are all perpendicular to CD, but the only one containing A happens to be line AD. Now, planes parallel to EFG and containing point A. Now, plane EFG, that's this bottom plane right here. So the only plane that is parallel to the bottom plane happens to be the top plane, and it contains point A. So the plane is ABC. So plane ABC is the plane that is parallel to the bottom plane. And that's example number 1. Let's look at example number 2. Okay, for example number 2, it says the given line markings show how the road in a town are related to one another. Name a pair of parallel lines. Now remember, just because 2 lines look parallel does not necessarily mean that it is. We have to look for the symbols in the diagram to determine whether it is or not. Now if you look at this diagram, you're probably thinking CE and BF are parallel. But no, there is nothing on them that allows me to say that they are. Now, if you look at these symbols right here, you can see that those symbols are telling me that those 2 lines are parallel. So the lines that are parallel are lines DM, and that's parallel to line EF. So only those 2 are parallel. Now for B, name a pair of perpendicular lines. In order to look for perpendicular lines, you have to check to see if you have that right angle box. Okay, so the only lines that I see parallel are going to be BM and DM. Or if I want to say BF and DM, that's also, acceptable. So we're going to say that it's going to be MD or DM, doesn't matter. Perpendicular, and that's the symbol for perpendicular, okay, BF. So those are the ones that are perpendicular. And yes, that little upside down T stands for perpendicular. Okay, so if you don't know what that means, write it down somewhere. That symbol means perpendicular. What does perpendicular mean? It means that the angle created is 90-degree angle. It's a right angle. Now the question, is FE parallel to AC. Now you can see here on the diagram that that is not going to be true because eventually these will intersect. So here the answer is no. They are not parallel. And that is example number 2. Let's look at example 3. Okay, example 3. Identify all pairs of angles in the given type. So we're going to start making a little list here. Okay, the angles that are corresponding. Now remember, they have to have the same position from on the left-hand side and on the right-hand side. So for example, angle 1, this one is in the second quadrant, you would say, is going to be corresponding to angle 5. So angle 1 and angle 5. Angle 2 is going to correspond with angle 6. Angle 3 is going to correspond to angle 7. Angle 4 is going to correspond to angle 8. Now those are all the corresponding angles. Now let's look at the alternate interior angles. Alternate interior angles, they kind of look like they're going to create an X. So 2 and 7, 2 and 7, 4 and 5. Those are your alternate interior angles. Now your alternate exterior angles would be 3 and 6, and angle 1 and angle 8. Now our consecutive interior angles, those are the ones that are on the same side of the transversal. So that would be angles 2 and 5, and angle 4 and angle 7. And that's example number 3. So make sure, guys, that you guys are completing the extra practice section that is on this section. And the extra practice section happens to be on page 70. Have a great day, guys.